Okay, just started, right? Let me quickly check for the voice modulation in case there is a problem with the voice. Quickly, let me quickly. Before we start, let me quickly check for the voice. First, let me change my speaker to my native Genius speakers. I have to close this one. It will come here. This will go here. So let me refresh it because I need to check. Okay, so I can see I'm live here. That means first thing is done. We are good. And yeah, so the voice is coming properly. That means our both is cool. And I can see the screen. The third one, first one is live, perfect. Second one is to check the voice is perfect. Third is the screen that I'm sharing is right. That I'm actually sharing the screen rather than my face. That's also right. So we are good to start the things. Okay. So let's quickly go to our channel. So our channel is Code for Coin. If anyone join, welcome to the hood. Welcome to the live session. We in this session we usually learn together about the Postgres. So it's more of like learning together. And in future, when I feel comfortable enough, I can start uh, crisping the node for you guys so we don't have to go through this manual process again and again. Okay, so we are good on this one. So far 50 videos is done, for subscribers are there. Thank you very much for your support, and I will continue to deliver the high end value that add into your career and might be helpful for your future endeavors. So that's the first thing. Second thing, if you are coming for the first time, make sure you subscribe the channel. And there are a couple of links that you must follow. First one is my LinkedIn account. Simply go there and subscribe. Reason is whenever I am done with this one, I try to write article or very crisp notes about this one. And I also put some visual things. So if you are interested, make sure that you simply go and follow me because you're gonna get good content there apart from this one that will hardly take 1 or 2 minutes to read, but it will improve your overall understanding at the ground level of PostgreSQL, right? Second, and that's the second. Third is the GitHub. Once you go here, github.com/code for coin, you will see this repository SQL with a structure query language. Go to the fourth directory that is SQL 0 to 0, and here I'm trying to curate the data that I learned so far, and in a very interactive and structured manner. You can simply go one by one in case you want to have best of Postgres information or SQL information out there. It include the exercise as well, so you will find very relatable exercises. So it's going to be really helpful for you to start from the scratch. Or if you're preparing for an interview, that's also good. If you're preparing to switch the career into database or something, it's also cool. So if you go here to leave the first one, that's initially that I started. I need to have a roadmap, so that's why I created. Start with the first and second. But if you want to check, go to the second first or the syllabus because it's gonna give you the overview of this one. So right now, week one is done. We took like 14 days. I think it was like 2 weeks, but we are starting to learn. That's good enough. Okay. So today we're gonna focus on where clause and or not. So we're gonna focus on the filtering the data. So far we read about everything. Let me open my relation database management system and the my client base UI. So what I have to write here, where clause PG admin exercise. So we are taking the official documentary as our learning path so that even if we stray from this one, we are going with the actual information provided by these people. So we should be good. We should not be that bad. So today we're going to talk about data filtering, right? So I think it should come under queries. Yep, the overview, then table expression, from clause, where clause, and then uh, as like table expressions, from clause, where clause. So I found the where clause, but what we need is where with and or not. Okay, so do we have those kind of union, order by limit, values, list, queries with This one recursive queries, common table expression, metallization, and data statement with streaming. So this is something we're gonna do later, but what I need right now is something where clause and others things, right? So we need to find it. No data definition, no data manipulation, no queries. I already said data types. In. Let's check for function and operator. I think operator should be because and or this not is an operator, right? It operates between two expressions. So logical operator, compression operator, comparison operator, mathematical function and operator, string function operator. So we have the function and operator, the case, window functions, aggregate. Yeah, we have a lot of them. So exists, so subquery expressions, we have too many. But right now we are focusing very keen to the things. If in future is required, we will come into this one by one and we will try to explore this as part of the life. But right now, no. We are logical operator and or and this. So what we gonna do is so and or and not are the logical operator. So this is something we're gonna learn. Apart from this one, we have comparison operator and functions. So what is it? Bit comparison function and operator. And we have here do we have anything? Between, not between, between symmetric, not between symmetric, is distinct, is not distinct. I think this is a fun, like I can like get into this one. I need to check how it is like distinct and okay, so there is a distinct here. I check between operator group. Okay, so let's not go it. We need to be very precise at the moment. So let's once this is done, we have a time. We can allot 1 hour and then we can go back from the scratch and we start doing everything from this one. But right now we are super focused on our thing, so we are not gonna touch it. So this is something we need to learn today. Logical operator, and then there was one overview and this overview, then table expression from where group by having and group by set. This is something we're gonna do later. So this is not something we need to touch at the moment. So we need to work on this too. And remaining these things we can park for time being. We don't need to touch it. But I want to check this one. Numeric plus, minus. Okay. Okay. So we do have a lot of things here. I think it's fun if I do read it, but not right now. This is not needed because there's always extra to learn. But right now we are focused on where clause and logical operator and or and not a logical operator that we need to understand. And where clause are the filter that we need to do. So today our study gonna start with this one where we're gonna study with overview, the table expression from, and then where, and we will stop here, and then we will simply go here when we start reading about logical operators. Perfect. Yep. So far we are good. Any questions if somebody joined here? Let me quickly go to the live. Uh, anyone joined? So nobody joined. So first thing first, I not uh I'm not going to this like uh 1 hour and 30 minutes. I don't want to exit this one because after that I have to do a lot of things. And what happened that I got indulged myself so much into this one that I forget the time and I exceed the time limit, and this is something wrong. So three session gonna be 5 minutes break after I did 25 minutes. So you also get a breathing time. Okay, so 5 minutes first introduction, 25 minutes for this one, then break, like 25, then break, 25, and we are done. Okay. So now we're gonna be doing 25 minutes of session. So what I'm going to make sure that what each session is going to cover. First 25 minutes is going to cover from, then it's going to cover the second pair, and we're going to start with logical operators, and the third session is logical operator. Okay, so we are good. We can get started, right? So let me start the timer. We are going to start. Perfect. We have started. So let's go to the overview query. Let me open it in a new tab. So we have the proper tab. So we are into queries, right? And I need to open something to write on the note. So we starting this session with the queries, and we know what is query so far. We are not someone who is not aware of the queries. So you know that the queries are nothing but the statement, the communication we do with the relation database management system using SQL, structure query language, where we query about something and it gives us the result, because SQL is a query based language, or it is a very declarative language where we declare something and we get the result. So it's a day 15, and today we're gonna do about what, where, and logical operators. And logical operators, what are they? They are and, or, and not. Perfect. So we're gonna cover this one. So let's quickly dive more into this one. Let's quickly get into it. So the process of retrieving or the command to retrieve data from the database is called query. We got our definition. So what is querying? Query is nothing but process of retrieving or command to retrieve the data from a database. But to make it very simple, the because SQL provide to you the declarative ability, because you are not doing anything tell the you are not doing the instruction to the relation database management system to go connect to this one, fetch everything. That is something he take care of it. What you have to do, you give the query, you give the query that what you want from this, and that's why it is called query language, because it's a process of retrieving data, or it's a command to retrieve the data from the database. That's why it's called query. So the process of retrieving or the command to retrieve data from database is called query. In SQL, the select command is used to specify queries. Okay, exactly. I told you that. The select command is used to specify the query. So you remember that I told you that your relation database management system is a person who is in charge of a big plot, or it's a owner of a big land. You communicate with him and he will develop this one. So it's like the operation manager. You go there, tell her that you need to build it. Okay, okay. So he's like, okay, I will create it. He immediately go sign a plot and create first floor. Okay, ground floor you can say, right? So that building is your storage, right? That is database. So database is nothing but a storage where you store your tabular form of data, or it's a place of organizing. So database is nothing but the collection of the data, or organized data, you can say. So database is a collection of the data. Simple. Okay, you don't have to make it very complicated, right? But who is creating a relation database? But on whose demand? Our demand. And how we are demanding? We are demanding through SQL query, right? So that's why SQL is querying language where you instruct this on what you want rather than how you want. Okay, that's why it's declarative language. So relation database management system goes there. He create the first floor by default. Okay, once you tell them create a building, it always create that ground floor, ground floor, right? So this floor is called a schema. Okay, so every floor that we're gonna create is a different floor, that is different schema. So in a schema or in a floor, you have similar kind of data you store. So there's a distinction within the building, that the floor number A, floor number B, floor number C will have different type of data, but the data inside those is gonna be relatable data. Okay, so now the floor is done. Inside each floor, you have a big cabinet and the corresponding tray. So cabinet is empty at the moment. Tray is there, and that's a big tray. No division, nothing. There's no partition. It's a simple uh, tray. Okay, it's a square tray, no division. So now what happened? You need to tell that how many division you want in this one. So how many different type of data you're gonna store it. So suppose you want to store ID and name. You create two division by placing one slab. One gonna store the item ID. Second gonna store the item your name, and this partition gonna apply on the all the trays that is either inside the cabinet or outside the cabinet. Once it's done, you ask them that for the first object, first entity, you put the ID one and the name is Nathan. You put it that one, you took that tray and you slide in the cabinet. So now the cabinet that was initially empty now is filled with one tray with partition two ID and this one. Perfect. That called insertion. Now if you have to delete it, you delete this statement, okay, and you so delete what happened, go and start looking for this one, and based on condition will take. Simple. So I'm not going to delve into much. Again, this is what happened when I get very comfortable with the things. I started moving out without that's I need to focus on. So here are the things. So what it says in SQL, the select command is used to specify queries in the general syntax of this with queries with 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 queries select list from the table expression short specification. Following section describe the detail of the select list, the table expression and short specification with queries are treated last since they are an advanced feature. Okay, so right now we are not going into with this one because that's also part of learning. I think this is somewhere here with yeah, select in with the statement. This is the one. This is called common table expression, and that's we're gonna learn as part of our learning. I think CTE is at the bottom somewhere. See here. You don't worry about this one. Everything is covered. If you follow this step, you will be 90% ready. The remaining 10%, I think 90% you are ready with the learnings. 10% is something you need to upskill by doing a lot of question from post your lit code and other platforms. Okay, so let's leave this one CTE common table expression. What we have to do, we go with this one. So the logic is simple. We already covered this in our previous live session, so you don't have to worry. You have the knowledge, but let me reiterate. The select what it does, I told you the cabinet is there and initially is empty. You insert the trays, right? And each tray have the same structure, the division item. So initially the tray will be empty, right? You create the division again is empty. There's nothing in the source. You started putting the values, okay? And then you started sliding in this one. So what select does, it will go into that cabinet and start retrieving all the trays that are inside the cabinet. It does that, okay? Now I slide out the first tray, then second, then fourth. Okay, on the first tray, then I took that out. It says that get me all the items in that tray. Suppose there was two, right? ID and the name. I saw two items. I picked them up. I put that in my basket to give it to you so that you can see that. Then I took the second tray, took it out, put that one. Third tray, I saw IDs there, but name is not there. So I can take one item and place it. The other item is gonna stay empty because the tray was empty, right? The partition in that tray for name was empty. So start what it does is that it says that when you started retrieving all the tray one by one, you have to get all the item that tray holds. That's the start. Okay, assuming that there is a table called table one, the command would retrieve all the rows and the user defined columns, same thing. So the trays are nothing but row that represent one entity, and the partition created inside each tray because it's gonna be same tray because every tray follows the same structure. The partition and the item storage by is nothing but the item belong to that entity or nothing but the detail about that entity. Okay, so it's a column values. So method of retrieving retrieval depend on the client application. For example, the PGSQL program would display an ASCII table on the screen, while client library will offer a function to extract individual values from the query result. Okay, it depends on the what kind of connection you are forming with the server. Like if you're using simply PG admin, the interface PG Postgres community provided it. You can simply use SQL and command line. You are using command line, then it become a bit tricky. It become different because it's more of like direct command chain, but it's not that difficult or different. Just a bit. What it says, the select list specification star means all the column that the table expression happens provide the same thing. All the item inside the tray, you have to get that out for you. A select list can also select a subset of the available column or making the calculation using the column. For example, table 1 has the column A, B, C, but the query is like A, comma, B plus C. So I told you the same thing. This select statement gives you the power to take all the trays inside the cabinet and then you can pick the item. Since you're picking it, you can play with it, right? So it says like suppose there is a cabinet uh how okay, so there's a cabinet about a person income. So there will be person ID. So there is a tray. Okay, initially was empty. There's a tray. Each tray have four partitions. So like trays like this, there's a partition. Let me show you in this one. I forget that I have this one. Okay, suppose in a database, this is a public by default that is created, and this is something I created a floor where I'm trying to hold the information about the employees salary. So I will create one salary floor. Inside I create one cabinet. So the cabinet gonna look like this. Okay, so initially empty, and the it will have a tray, and every tray gonna have the same structure. In this tray, I'm gonna have four divisions. First one will store ID item, second gonna store the name, third is gonna be salary from job one, and second are gonna have the salary from job two. And whenever you insert this data, you're gonna slide here. Okay. And it's gonna be entity for some ID for entity one or person one, second, third, fourth. Now what happened? You start retrieving all this data, but you want to show the ID, the name, and the total salary. You don't want S1, S2, you want S1 plus S2, right? So what you have to do, you have to go and access all this trays, right? All the entity. So you write select. It give you the power. It tell the relation database management system you are the client. Tell him it goes here because of the select. It start retrieving everything, and it started after retrieving it will give back to you. So if you want everything like ID, name, S1, S2, you simply write a star from it. Tag from is like it tells the relation database management system which cabinet it has to go. So we have to go with this DB. DB is your employee, right? EMP. So you have to go to the EMP database and get into when you have the current you have to get into, you use this dot condition dot. Then which floor? Salary, right? And then which cabinet you have to do EMP underscore salary. So you will write here EMP underscore salary, right? And it will retrieve this thing and it start give it to you, like it will give you ID, name, salary one, salary two, ID two for the second trace. There's one and this one. This is something you don't want. What you want ID, name, and total salary. So you will write select. You want that when he's retrieving all the trays, get the ID from the tray, then get the name from the tray item, then you do the S1 plus S2 and give me it as a total salary. Now what it will retrieve is retrieve ID, then name, then total salary, like this for all the entities. Perfect. So that's the power of the select statement. And simply you can also do that 3 into 4. Yeah. So in general, table expression can be complex constructs of base table joins and subqueries, but you can also omit the table expression entirely and use the select command as a calculator. So you don't have to write every time the table expression here. You can simply, if you want to do something as like simple operation, and you don't want to involve any table expression, you can simply write select and this one. So what it says like select 3 into 4 go to the public and sub table or something like it's give that you when you don't write from expression, so it won't go to any of this one, it will compute this thing as an expression. It will take it as an expression. This is more useful if the expression in the list return a variable result. For example, select random, we can run it. See? So right now I am filter, right? So I don't want to use any table expression. I will simply write 5 multiply 6, and I want to run one more 3 plus 4. Okay, and I just want to run this one, so I will go with this 6 into 5 30 and 4 plus 3 7. So what happened? I'm not using that from clause. From is like it introduce the concept of uh, accessing a table. Okay, that's why it's called table expression. But since I'm not doing it, that means the RDMS won't go anywhere. It will just calculate this one. The next step, right? So with this select statement is done, let's move to the next one. Uh, Overview. I think overview was table expression. Perfect. So table expression has started and we're gonna cover two things. So the first one is from clause, second is a where clause. We understood that the where select is to retrieve all the trays that we store into a cabinet. Cabinet is nothing but table where we store row and column values. So each row, each tray is entity object, and each tray partition the value it holds is the detail or the object belong to the entity, the detail about the entity that we have. And each tray obviously follow the same structure. It will have same number of division, partition, whatever you want to say. Now we will start with the from clause. So what a table expression computes a table. A table expression computes a table. What does computes a table is to process the table. That means it go access the table, it will retrieve the data from the table, and then it process the data based on your requirement, and then it get that data for you. Okay, so this is called computing. Computing is nothing but simply when you process something from raw to process or the desired result. The table expression contains a from clause that is optionally followed by where group by having clause. Perfect. The trivial table expression simply refer to a table on a disk. Okay, this is important. The trivial table expression simply refer to a table on the disk. Same thing. So-called base table. So it is nothing but it give you the direction towards the data that we want to access. So it's just a reference. It's a address to a table we want to play with, we want to compute. But more complex expression can be used to modify or combine the table in various ways. That's something we're gonna learn more as we progress. We don't have to bother with this one. The optional where group by having, we're gonna cover this one as part of our roadmap, so don't worry about this one. So from, so we don't have to worry about this one. Today we're gonna cover after from we're gonna cover where. So let's quickly go into it. The optional where group by this one clause in the table expression is part of the expression, but it's optional. You can put it, you don't put it. And where we are very clear because we covered it in our live session, where clause will let the data, the entity, be part of retrieval data. It will be the part of the data that will be shown to the user if the expression result a true value, only true value. No null, nothing. It has to be true. If it's null, it's a false. It will drop. It has to be true. Okay. Check statement is different. Check is a constraint. It says the data will throw an error if it return a false boolean data type from that expression. So if it is true or null or anything else, it will pass it. So, but if it's a false, game over. It's gonna throw error. That's the difference for the check, and that's really critical. People don't understand this one, and they simply thought like junior SQL developers, they, they were like that check gonna pass pass only true, not the null. It will drop the null and other thing. So any questions so far? If somebody joined, let me refresh it in case somebody has a question. I don't want to move before we are good on this one. Okay, there's none. We are good. We can simply move ahead. Now the from clause. So all this transformation produce a vital table that provides the row that passes to the select list to the compute output of the query. That's what I'm saying, right? So from is a reference to the table where group by and having are the operation we do on the records when we uh, started accessing those tables using the select statement. And select is nothing but it gave you what kind of a data you want to take from this array or this information you are left with. Okay, so if I have to make it very easy for you to understand, we will go with the same thing. Okay, so there are few things you need to understand. That first in select, then select a list, what you want as a list, then from, then table reference or address, then where, group by, and having. Okay, so first thing is from. It will give the address to relational database management system that which cabinet he has to go. Perfect. Second one is a select statement. So it start accessing all the trees one by one. This will make sure which tray has to be taken, which tray we don't have to take in, which trays we have to group together to be part of one group or not. Okay, this is going to do that. Once that is done, then it is started applying this logic of output that will be shown to users, like either it can be directly a column or an expression of columns, like column one plus column. That what we did here total side. Perfect. We will learn more as we go. Okay, so the from clause, it says the from clause derives a table from one or more other table given in a comma separate references. Okay, so that means what is from expression? From is a reference to the table that is stored in the text, or it's an address to this one that the relation database management system has to go and make a connection, and then the later things will happen. So this is just the address to the table relation database management system has to get access to or get a connection to. A table reference can be a table name, possibly schema qualified, or a drive table such as subquery, a joint construct or complex combination of this. So you don't have to worry what is subquery or this one. This is something we're gonna cover in future. If more than one table reference is listed in the from clause, table are cross-site partition product. Okay, the table are this one. See in the below one, we will check this one. Don't worry about this one, but this is important. So if there are multiple call table references with a comma, okay, they're gonna have a Cartesian product. But from table, you will get only one data set. Okay, remember that from table you will get one data set. You won't get the multiple data set. You will get always a one data set. How it will do, we will talk about this one. The result of the from list is an intermediate virtual table. I told you the intermediate virtual table that can be a subject to transformation by the where from group by having clause. So these gonna make a transformation either by dropping, by grouping, by processing, by making some constraint, whatever it is. But the from clause of this one gonna give you one virtual table. Wow. It won't be two, won't be three, it will be one virtual table. Okay, virtual table. Okay, so how it is it uh, when a table reference name a table that is the parent of the table inheritance hierarchy, table reference produce a row of not only that table but all of its descendant tables unless the key word only precise the table name. However, the reference produce only the column that appear in the name table. Any column added in the subtables are ignored. So what does that mean? So what it says, when a table reference names a table that is the parent of a table inheritance hierarchy. Okay. So I think there is a concept of hierarchy in Postgres. So I need to learn that. I can't comment on this one, but I think I got it. Table reference produce row of not only that table but all of its descendant table unless the keyword only precede table name. However, the references produces only the column that appear in the name table, any column added in the subgroup. Okay, so I got pretty much understood. I'm not sure how accurate I am, but this is something a gray area. Dude, we're gonna take a break of 5 minutes and then we will back and we will continue on this one. I think we will not cover the joins. Don't worry about this one because for the join we have a separate uh week 4, week 3, group 5. We have this join, so you don't worry about this one. We will come here for the expressions. We will just have this one. We won't go to the join tables. We just have to understand from, then where, and then we will simply move to our op this one. Okay, so don't worry about this one. I have created the list we have to follow very rigorously, and in future when we are very good, we will come back for the live session for like 6 hour of marathon or like 8 hours of marathon something, where we will learn everything from scratch again. That's when we will cover everything one by one, one by one, one by one. When I have good number of subscriber and they join the live session, then we will do that one, but not right now. We will be sticking to this one because we have to make sure that we are doing the things proper. So let's take a break. Okay, we are left with we have 1 minute, dude. Ah, nothing beats a good beverage. God bless everyone. Okay, guys, bell rang, so we can get it started. So I started this 125 minutes of session. So we are very clear with the from, right? From give the direction or address to the relational database management system, that which table it has to access. You can provide multiple tables here, but if you provide with the comma separation, they're gonna give you cross products. Okay, but ultimately, the from will ensure that only one virtual table is created, no matter how many tables you give in this reference table. Okay, in the reference table class, it's going to be one virtual table. If in case that I learn from this one that if a table, parent table, we are accessing from a schema, then the table P, and it has an inheritance relationship with some C. So what happened? All the columns, all the entities that trace from P trace or entities plus C trace or entities gonna merge together. The condition is it will put all the columns, all the partition values, which is same as this one. If it has some extra because it's inherited, they won't be the part of this one. Okay. But in case you just want to have the entity from the parent table, you don't want to get the information from the child table, you simply write only keyword with the table name that is schema.p. But this is something I'm not putting much thought into it because that's for future reference. But I do want to learn about inheritance. This is something enable me to be a good SQL developer in the future because I can make the actual relationship that exists in the real world into the database system. This is the one. Instead of writing only before the table name, you can write a star after the table name to explicitly specify the descendant table are you can instead of writing only before the table name, you can write a star after the table name to explicitly specify that the descendant table are not included, are excluded. This is wrong here. It says instead of writing only before the table name that we were using only to make sure the only the parent data came in, like see here, reference row are not only the table but also of its descendant table unless the keyword only precedes the table name. However, the references produce only the column that appear in the name table. Any column added in the sub tables are ignored. Okay. It says if you use the only, then you will get the only data from the parent table. And instead of using only, you can simply write the parent table name dot star. So if you give all the information, all the entity, it will select only the trace from parent table, not from the child table. But it says that specify explicitly specify that the descendant table are included. But that's not right. It should be excluded, not included. I might be wrong. Let's check with the cloud, and I'm pretty sure it should be how I told you, because that's the sole purpose of only to restrict its access to the parent table, not get into that hierarchy relationship and go into the child table. Okay, so uh, I think it should be excluded as I am specifying to access only the table or entities of parent table. You are actually mistaken here. They see, that's the thing. You are actually mistaken here in the PostgreSQL table inheritance. The star suffix explicitly means including descendant table, that also default behavior. Ah, That's why you should exclude. Okay, got it. So that's the one. Right. So if a parent table have a inheritance relationship, and instead of writing all, so when you write this, automatically include all the child tables, and it start include the rows from the parent and all the child's table by default. But if you write the star, it will explicitly tell the people that this table have the inheritance relationship with some parent child table, and we gotta include those records as well. And when I use only, tells that it has that inheritance relationship with some other tables, but we are gonna ignore those child tables. We're gonna focus on this one. So instead of write these two are same, but instead of not writing star, you should write it. So it specify that it has that relationship. If somebody using it, they won't get confused that this table have extra column that is not actually present in this table, or it have more trays, more entities that are not part of this one, because this is something coming from where child table. Okay, so to make avoidance of this thing, I think we should go with the explicit or explicitly including descendants. Now I want to ask a question. So when I include descendant, do I union their data for the data, or it's cross product? I think it should be union. Union all. When you query a table including descendant, PostgreSQL collects rows from both the tables and then return a single combined tables. Okay, so no joining or cross product. That was right. So you can simply say it's the same as this behavior. Union all, union all, union all. But if vehicle has the car and truck as child parent relationship, it's gonna merge them into single table. It will keep on adding, but making sure that the vehicle have that blueprint that whatever the column vehicle had, the same number of column will come from car. If the value is not present, it will get the null values for that or empty value for that. Okay. Mm. So join, we are not gonna do it because that's part of some other day, and we are good so far. We are literally good. So the cross join that we are talking about, comma separate, right? We're gonna do it in future, so don't worry about this one. So table expression is done. Now what we have to get into the where clause. This is important. Okay, and it is not much. It is simply this one. And we have already done this as part of our previous learning, right? But we're gonna do it again. So what is where clause? From clause is the referencing table expression clause or table reference keyword. Where clause is a filter keyword. It will filter out the data that is not required or entities that are not required or does not follow a certain condition. So how it happened, let's write it down. The syntax of the where clause is where and the searching condition. But rather than searching, I think filtering condition make more sense to me. Where search condition is any value or expression that return a value of type boolean. I told you, where clause allow a record, a tray or entity from that cabinet or table pass and get into the like, to get or become a part of that virtual table from expression it will give, right? From enables you to access this one, and ultimately it gives you a virtual table on which we select and retrieve the data for the customers, right? So this condition will make sure that which particular entity, which particular tables are qualified enough to be part of that virtual table. Because the virtual table we are creating is based on our requirement. Let me tell you example. So suppose what happened, again, we will go with the same example of this tray, right? So in this tray, we have, so this is the cabinet where I have multiple trays. That means the information about multiple employees, salary, right? And each tray or the information about each employee have four things: ID, then name, then the salary one and the salary two. Okay, you can say is the base salary and this is the is your commission or is your bonus. Okay, so you don't have to worry. Now, if I write like from the floor, which floor is it? This cabinet is present or we have stored it is in the salary schema or salary floor. And the cabinet name that we gave it to or the table name we have given to temp salary, right? Okay, so what it does, it will tell the relation database management system that relation database management system go to the DB salary. This is a public schema and this is your salary schema. It goes to the salary schema, then access the cabinet. Which cabinet is it? Yours temp salary. Okay, and once that is done, it will start accessing all the cabinets trays, the cabinet trays one by one. Okay, now I told them that I need information in tabular form, and what I need ID. So whatever the now this gave me that virtual table. Okay, from this one I need the ID, the name, and total salary. And total salary is nothing but S1 plus S2 as total salary. And select is like, so whatever the virtual table is coming from this one, I need the data in this format. Okay, virtual table is like it will read every trace and store that in tabular form. This is a virtual table that is created, and then this virtual table is being created in this format, the output format. This is the from reference format, and after that it will convert to your output format or the select list format that user want, or or it can be user request format, and this is from reference format. Okay, so it will access it, get that virtual table created, then it will convert it into the user required format, and then it's sent to the user, right? But right now it was simple. It was just read this one, get virtual, and this virtual get converted to this format because it's ID, then name, then salary one, salary two. But the user want in this format ID, name, and then S1 plus S2. See the difference? This was the base virtual table, and this is the output virtual table based on user requirement. And this is based on the from statement. Now, in this one, you see it is coming this one, but user need only the salaries, total salaries, which is greater than equals to $50,000. If it is below that one, they don't need to worry about this one, right? That means from this virtual table that have all the data I want to drop, I just want the data that will be part of the user virtual table. So there's two virtual table. First one is from virtual table that actually came from the system. Then it got converted to user virtual table that is shown to the output or user. Here all the data of the employee salary is there, but here I want the data for this for the ID, name, and total salary should be greater than equals to 50,000. That's my requirement, this condition. And this condition we can apply on this one when it move using where clause. What where clause does, it filter data based on a filtering condition. And how we do it? You simply write here first table reference from which floor is which database is your employee dot get into that database, get into the floor where my table is stored. Which floor is it? The salary. And which cabinet or table I want to access? EMP salary, right? So what happened, right, with this logic, it will go and create a virtual table by accessing all the tray one by one and take that data or item from there. It will take ID from tray one, then the name, and then salary one and the salary two. Similarly, for entity two, it will do the same. It will create this virtual table. This virtual table is created. Okay. Now, before it get into the select statement, it sees there is a filtering condition. That means all these records are not eligible. All the trays that I'm taking out one by one is not eligible to be part of this virtual table. Okay. Why? Because it says that S1 plus S2 should be greater than equals to 50,000. And I saw ID1 does not fulfill that condition. ID2 does. So now ID2, the name and S1, S2 came. Okay, it become uh, ID, name, S1 and S2, and so on. This is the virtual table came from here, right? Now what I want is, now this is output of the from virtual table. Okay, right? This is the virtual table from of virtual table from class or the table references. Now I want to convert it to the user defined virtual table that user want to see. What it want to see? It want to see ID, then name, then S1 plus S2. And we apply the condition using select this one. And this will be ID, name, and total salary to the users. See? So initially all the data came here. Then it filter out the data based on the condition that the S1 plus S2 is greater than 50,000, and then the output is shown as ID, name, S1 plus S2 to the user. So this is the final w- from virtual table, and this is the final user defined virtual table that user gonna see. We are good? Perfect. You can see here is the same condition. We are not going into this one join because this is something we're gonna learn as part of the process. But if you see here, ultimately, where allow a data to be part of user defined tables when it represent or it gives the boolean true value for a given expression. Okay, it says that table. So again, this is the same dot notation in the table. A means that the entity of A dot ID, the column or the value or the item ID should be equals to ID of BA element. If it is plus the B value is greater than 5, then only this condition is applied. You will get confused. Don't look into this one. Try to understand what I want to say is this is the way you can put your condition. First one is greater than that in operator, then in operator with the condition from the table, then in operator using the filter again, then between, then exists. So this thing we're gonna cover, but not right now because everything will be part of the process. We go one by one. Okay, let me show you the this one. So now join. This is the week 3. Here order by limit distinct sum giving. See between came right. Then inner join, self join, everything came. Some subqueries logic came in, everything is there. String function is there, statement is there, union there, date there, so everything is there. So you don't have to worry. We will go there one by one and we will make sure that we get as much as in say in operator is there, between operator is there, like operator is there. So we will come to know about that one. But ultimately what it means that for every record it try to retrieve from the parent table, from the reference table, from the reference table, it has to fulfill this condition. Then only that entity, that tray from that cabinet become part of the user defined virtual table. So this is the same thing. So what is say f the this table is the table derived from clause reference table. Rows that do not meet the search condition, I think not search condition, I think better should be your filter condition of the where clause are eliminated from DBT. So I think rather than search, I think filter condition make more sense to me. Notice that the use of a scalar subqueries as value expression just like any other query in the subquery complex table. So what happened is it is checking the condition. See for example, when it take that tray out, it check for the partition C1, it take that value or item and check whether it belongs to any of this list. If it is true, because this gives the boolean true or false. That means that record is eligible to the part of user defined table. Similarly, you can use in, and I told you again, what select statement gives you. Select statement gives you a list of items, right? From the virtual user defined virtual table. What is it? It take all the tray from P2 and then take only the item C1 from this one. And here is the column only C1, right? So we are good. Then C1, again, same condition with the where clause. Again, it is filtering out this one. This is called subquery. It is the part of the main query, but not exactly this one. So it's a subquery. Query within query is subquery. One between condition we're gonna learn, exists, we're gonna learn. Okay, so don't worry about it. So exists, I think it means like for this record, this particular record, the tree when you pull out, if this expression results in at least one record, exists means there is a record. At least one record of one entity came from this one, then that means it's a true statement and we have a value. Or that record become eligible. See here, ftd.c1. So this value inside the subquery is coming from the entity I am checking for. It will take that entity's C1 value and check with the table 2 whether is greater than equals to, and even if you don't write C1, you can simply write 1 2 3. It will give the number of records which pass this thing and exit. Like again, if it is have at least one record, it pass. If zero, it's gonna give me zero. That means it's failed. That means it's not fulfill this condition. This one is really interesting and it's time consuming as well, because for every record you are running complete scan on C2 table. Okay. So that's the where clause, nothing much to do. But when we progress, when we start doing more of exercises, will be much in clear. But we need to understand their operator like greater than this one. So that's the logical operator. This should be your relational operator because it establishes a relationship. It establishes the relationship at the value level. An in operator, then bit operator, a between operator, then exist operator. Let's go. Let's go. Goodbye and having we will learn in future, but right now. So we learn so far two things. One is from is a referencing clause that enable relation database management system to refer to a table or get the address to a table. Okay, or let it go to the to provide the address to a table or cabinet inside a building or database. Second one is where clause. So whenever the from commit started accessing all the trays inside the cabinet, and it will make it into virtual table, and there will be another virtual table if where clause involved. What where clause does, it check the eligibility of each tray, each entity, whether this is the part of user defined user required virtual table or not. Okay, if it indeed passes through that condition, it goes into user defined or user required virtual table, else it will get dropped. Okay, that's filtering condition. So from is referencing table clause, where is filtering data. So that's table, this is data. Filtering entity or object clause. Simple, you understand that. Okay, so with this, I think you are clear on one thing that's very crucial, and you should be thinking that the statement was select when the select list how we want to, or it's nothing but user required virtual table, right? How it wants. But from it gives the relation database management system reference or address to the table or cabinet he should access. Correct? And then where it is a filtering or allowing eligible entities to be part of user required virtual table, right? But if you see, the first thing I do even before the select is created, I need the data, right? I cannot have a data until unless I access that. table or that cabinet or the data, right? That means the first clause or the first part of this grammar is gonna execute is from. Once I have all the data access, I'm going to see the eligibility of each entity or the record. That's the second. And then I will format it based on the user required virtual table. Then it's become third. So that's the order of execution from where select. Good. Perfect. So we are done everything on time. So we are good with this one. So I can close this one. So group by having we will set we say take this one window function dude, this is something really important. Window function, we have window function as part of our learning, so don't worry about this one. We're gonna cover as much subqueries basic correlated subqueries. That's perfect. Case when statement string date, this one, this is not one. Window function. Okay, so you don't have to worry. We have everything lined up. So if we cover this in the same fashion, we will make sure that we become at least 80% ready for the interview. Remaining 20% involve like 10% of code solving, preparing yourself how to handle the patterns, how to handle the queries asked during the interview. And the remaining 10% is working on yourself grooming, communication, aligning your CV. So that's the 10% left. But we will be pretty much done. So let's quickly take a break of 5 minutes. I will have my tea. You also have something, grab water or something. Keep yourself hydrated. Okay. Anyone join, buddy? Like we have like 2 minutes left. I don't mind talking with someone. Make sure you keep yourself hydrated. I do this. Water is best thing ever. Buddy, I want to extend my heartily thanks to the people who subscribe my channel. So I got 4 subscribers, and out of 4, I think I only know one person, my friend who subscribed very initially. And the remaining 3 are completely strangers. And to be part of this journey, I'm really thankful. And I hope we're gonna learn, we're gonna understand, we're gonna improve, and ultimately we're gonna execute. Oh my god. Sometimes I do say few things very deep. So that's it. We only left with 30 seconds. I will take a break of 30 seconds. Okay, guys, the bell rang. Our break of 5 minutes is over. Let's get started with 25 minutes of next session. And in this session, what we're gonna do, we're gonna cover the logical operator that gonna be complementary with the uh, where clause, right? That's the plan. So how we're gonna use here. Okay, there's nothing here that logical operator. Let's get this. Okay, let's start our session. Perfect. We have started. So far we are good. I already informed you. Mhm. I'm sorry. Okay, so we are very clear on the things that from clause is a reference clause that enable the relation database management system to access. It is an address to access the table. Then the where clause and it access and start accessing or retrieving all the entities or all the trace, all the entities and their corresponding information from that table. Okay, so that's the one. That become the first brute force virtual table. That it take everything. Then from this one, we need to make sure only data or the entities or the tray that are eligible for user defined virtual table is being filtered out using where class. It will filter out and remaining will be the actual uh, virtual table from class. Okay, that's the one. And then we will format it based on user required virtual table that's in defined in the selected statement, and then we will showcase to the user as an output. Okay, we understood one thing very clearly that where clause is a filter condition or filter clause. Where is nothing but a filter clause that allow only eligible eligible entities. Correct? That's we are very clear. So until unless the where clause written are true for that tray, that entity, it won't allow that entity, that tray to be part of the user required virtual table. So what we thought like where the expression should return true value. Okay? But what happened in real life, we can test an entity eligibility for more than one expression for more than one condition. Expression here is condition. Okay? How to do that is using multiple expression combined with operator. Okay, operator, and this operator that combine multiple expression, multiple condition based on logic is called logical operator. Okay, so so we are very clear that when multiple expression or conditions are being combined together based on certain logic, the operator that we use is logical operator. And these operator are mainly three such operator we have. One is and, second one is or, and third one is and we will learn them one by one. Perfect. So what it does, the expression one return a boolean, expression two return a boolean. When we do and, it give me a boolean. Okay, same thing with or, it gives the boolean, and not again it give a boolean. So ultimately, when I use this logical operator, it gives me single boolean, and that exactly I want for a where clause. I want a single boolean. If it's true, that particular entity or tray is allowed to be part of user required virtual table. If not, it will drop off. It won't be part of that table. Okay, but how we combine the multiple condition together? Okay, so why logical comes when we have multiple expression and we have a condition, logical condition. And how the logical condition is simple. Suppose I am testing my eligibility of an entity or tray based on two conditions. And how is it that it will become part of user defined virtual table unless both the condition is satisfied for this entity? Both has to be true, right? Second case, either of them is true. Third case, none of them is true. So what I say here, from that table or the cabinet, a tray is taken out and it will be part of user defined virtual table if this entity filter where, right, we are filtering it satisfied two condition C1 and C2 and both are true, then only it will become part of the user defined. On second table or the second data set that the user want to see or virtual table you want to see is either C1 or C2, either of them true. That means either true, false, or false, true, or both are true, true. Any, at least one of them is true, then it is part of this table. Third one is condition C1 and C2 both are false. Okay, so both are true, both are false, or either of them are true, either of them, right? So in that one, both can be true, then either of us also right? So this kind of condition, when we have multiple true condition, we have to have a pattern of boolean for a multi-expression filter condition. We apply logical operator. Okay. And how we do it is place here. So A and B are the condition C1 and C2. If it is true and true, A and B, it will give true. And that's what I want, right? Both has to be true. Then I will use A and B. If both are true, the final result of this expression will read as true because it give only single boolean, right? If OR is used, again it gives the true. But where it make the difference, it make the difference in this second condition. If A is true, B is false. And if I use AND operator is false because AND says both has to be true. That means like true. We give true. Okay. Then this one, true, this is null. I told you whenever you compare empty with something is always empty. Doesn't make sense, right? You cannot compare empty ball of a cup with a ball of full of beverage. Can you compare? No, empty is it is empty. But if it's a bottle, then you can compare on certain basis. You see, here is null. Yes. But it says true. Why? I will tell you the reason. Both are false. It false is false. False and empty uh, is false is empty and both are empty. then it's empty. So I am clear with both being empty is being empty, but what does and means then? And is but it gives false. 1 0 empty 1 0. I'm thinking for the logic. One empty bulb is empty. True makes sense. False, false. Mm-hmm. So 1 1 true 1 0 0 1 multiplied 0 and 1 makes sense and false multiplied. Okay, makes sense. For two null null empty empty is gonna empty makes sense. But true null null or true doesn't matter. False and null. So empty 1 multiply empty is empty. Uh, empty is turns out to be 1. But false is C. Dude, I can't understand the logic. One and empty is empty. It give me true. I just this thing. But if it's false and no 0, why this one is again zero false, but false with dude. I don't understand this logic how it does, but let us do something on this one. So A is nothing but your C1, condition C1, that's C2. Then we use AND operator for C1, C2, and then we use AND operator for OR operator for C1 and C2. AND usually means multiplication and OR means plus. And we have learned in data type that true and SQL or PostgreSQL can be represented as 2 or it can be represented with 1 or thumbs up. Let's say 1. False can be represented as F, 0 and thumbs down and 0. Let's take 0 1. Okay. So first condition is true true. Second one is false false. Then true false or false true. This is almost same. You simply switch, doesn't matter, right? If a condition give true, another giving false, is the same statement. These are two almost same. True true become 1 1. False false becomes 0 0. True false becomes 1 0 or 0 1. It's gonna be same. It doesn't matter, right? So this multiplication 1 multiply 1 1, that means true. 1 plus 1 is 1 because it can be 0 or 1. Okay. So if it is greater than 1, it's round off to 0 ultimately. Don't worry. 0 0 multiply is 0, then false. And then 0 plus 0, again 0, right? Let's check. Both are true, then true, true. Both are false, false, false. We are right. Now 1 multiply 0 is 0, and 0 multiply 0, 0, same thing, right? 0 plus 1, 1, and 0 plus 1, 1. Let's check out true, false. True, false here is again false, then true. False and true. False and true. We are good, right? Now, null means empty or unknown. If both are null, empty or unknown, it has to be multiply two empty things you are multiplying, two empty things you are adding is gonna be empty. Okay. Now, if it's true or null or true, it's gonna be same thing, right? How this thing is same. Now, false or null false. This gonna be one thing. Okay. It's ultimately a combination of true and empty and false or empty. How it gonna work for an operator that I need to understand. If you understand this one, it's gonna be really, really beautiful. But I want to see a logic being formed, or we can ask Claude. Don't worry, because I multiply empty with one. What and operator say? And operator say both has to be true. Both has to be true, and it's null, right? So that means it's empty. We don't know. So it should be null. My perspective, what AND operator say? It means all the condition I'm putting, everyone should be true. Then only it will return a true value. Okay, AND means multiplication that everyone has to be true and true. If null comes, that means I'm unsure about this one. So I need to understand, is the definition means all has to be null, or is the definition is the negative that we go with the check as well, that none of the conditions should return a false. If we are going with this one, then it will be true or one. Or if we go with the second one, it's gonna be false. Let's quickly check on this one, how it reduces. So we are checking for true and null combination, right? So null and true is null. Okay. And then that means we are right. It says it to be it true or true, we have to have all the condition return true value. But there is a null. Okay. So we are not sure how it gonna work on. That's why we put it null. We are not sure. But what all operators says? All operators say at least one should be true. For null to happen, at least one should be true, else everything is false. Okay. Here I can see one true, so it should be true. Is it right, my understanding? False and true. Right. We are correct on this one. Now let's talk about this one. There is a null and then false, right? What AND operator means, every thing should be true to be true. But now it's got confused. But OR operator, what it says that everything, how should proceed with this one? Okay, 1 second, let's not fetch this one. Uh, uh-huh. Everything. No, if not, then have you and no, it have the preference to allow us now overrides. Here, it should be at least one true, that's very true. And what about this one? And operator, or dude, I think I need to ask this one. I am getting an idea, but it's a bit confusing because I'm not able to put the idea correctly. So zero null, false null should be. false, null, false, and null. See, false and null. That's true. But how is it like this one? I understood one logic that for all operator, at least one should be true. So it was true, that's why it came true. Makes sense. Here was none was true, so then we have the value zero or null. And when we compare zero and null into OR operator, null got preferences and it will be here. Makes sense. And operator, if we go with the same logic, it says, oh, one should be false to be a false. And now it's one and null, it got null. Hmm. No, I got it. Now I got this one. It's interestingly simple. Okay, so I was going in the wrong direction. I was going into wrong definition. That's why it's really important to understand what is the core logic behind. Like for example, check. I told you that everything has to be the condition for the check statement should be false. Then only it will throw an error. Else it will pass. So that means true and null also passes this condition, right? Where clause here the expression should be true. Then only it will pass. If it's a null, it will fail. It has to be true. Nothing else. Okay. How see how this one? I checked up constraint. What is it will fail if you get false. That means if it's true or empty is pass. You see the difference? The difference is in the definition. Now for AND operator or OR operator, there is one primitive definition we need to go by. That is if there is at least one false, it will always return false, no matter what. It says if there is at least one true, it will always return true. Always. Okay, so now if you see here, condition 1 and condition 2, and I use AND operator, then OR operator, right? True, false, false, true, because there's gonna be one state, okay? Then true, true, and false, false. Let's write what AND says. And the condition is checked. If at least one false is there, it will be false. That 1 multiplies 0, 0 always come, right? 1 is false. Both are true, that means give me true. Okay, both are false, it give me false because there is not one. Okay, second one here, what it says that at least one is true, it will give me true. True, because there is one true, this is one true, it give me true. There is one true, yes. Is there any true? No, it's gonna be give me false. It satisfy this condition, right? Now let's go back to the condition number 2 and 3 that we were interested in with a null operator, okay? Which says null and true or null. And same here, null, false, and false null. Now what does and says? It says at least one should be true, then the entire expression gonna result give me if one is need for, and what it says, if at least one is false, it give me always false, doesn't matter. You see here, it is false, it will give me false. Okay, what true, what all operator says, it should be at least one true statement that come in, it will give me true result no matter what. It's true here, it give me true, right? That's the statement number one, so we are clear. Now second statement, what it says that, like, if there is one false, it give me false, there's no false here, right? Second operator says it will give me true condition when all the operation are true. Is all the operation is true? No, there's a null, empty. So it will give me empty. Here it says or operator that at least one should be true, then only it will give me true. That's the first condition. Second condition, it says that everything, everything has to be true, or everything has to be false. But is there any false? Everything true? No, there is a null. So it will get. Okay, so AND operator follow condition like AND is like multiplication. Okay, so and true is 1 and false is 0 for analogy. Okay, so suppose any of this has, even 1 has a 0, you multiply 0 with anything is always 0. Understand this thing. So and is like if there is at least one false, is ultimately false. You don't have to worry. That's the first thing. Second, all are true, then it will be true. One operator, right? 1 into 1 into 1 into equals to 1. You have to understand this too. If you understand this too, I think we're gonna get clearance on this one. Operator. This first one is at least one is true. It's like or is like plus condition 1 plus condition 2 plus, and true is like 1. So if you add 0 plus 1 or empty with 1, it always gives me 1. Simple logic is gonna be true. Second, it says all could be false, then it will give me false. Or all should be true, that it give me true, right? But this condition. If there is a null, it will automatically give. Now there is a null, at least one null. It will be null. Answer is clear. Okay, so if I have to define it like easier for you guys, so I think we can create one table. So this and is a multiplication for your understanding, and its value is 1, right? Or is 0 and it goes with a plus 1. Okay. Okay, so and says if at least one is, because it's multiplication. Okay, if one is false, that means 0. Directly put false here. Correct. Here at least one 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 is true because it's addition. You can add. So one is there, it means it have a value. So that means it will be true. 1 or 0, right? If there is a null, put a null. Is null, then put a null. Okay. All true, then put a true. All false, put a false. Same statement here. All true, then true. All false is a false. If you understand this much, I think it's pretty amazing. It's very simple, but it's very, you have to put a bit of mind. You need to understand there can be multiple definition, but which definition is being used for the condition or to implementation, you need to understand. And this is the logic. And is a multiplication. That means if there is any false, it cannot directly give me false. For all operator is a plus. So if there is any one true value, that means it will give by default to. Second, if there is a null in either of the case. This is for and. After this one, it doesn't matter. It doesn't matter is and or. If it's a null, it will give me null. If first condition check, second, third, fourth is same. If is there is null, is null. If everything is true, no matter is and or is true. If everything is false, it's gonna be false. Simple. So you need to go with this logic. If the first one, this check, then second check, and third check, you are good. First one, okay. If there's and operator everywhere and is used between the condition, if everything is false, if at least one is false, because it's multiplication, right? By default, if there is any 0, multiplication give me 0. So if it's at least one is false, it was false. For or operator is addition. So if one of the condition give me true or one value, everything gonna be 1. So at least is one is true, everything is true. That's one condition. That's the order. Second is if there is a single null, ultimately give the null. After first condition, second condition you need to check. Third is if everything is true, it's true. If everything is false, false. You don't have to check whether it's and or. And I think this is something we can see here as well. So both are true, doesn't matter and or, it will be both true, right? Now we will go with same order, right? Same order. So if for AND operator, what is if there is one false, it's gonna be false. So let's see if there's a false. See false here. Give me false. Is a false here? See is empty, it doesn't matter, it's false here. That's the first one. Okay, we are done. Or operator, we also check. If there is one true, because addition is one, there will be a one with addition, it always give you one. So it's true, it's true. See here. Uh there's nothing. That's the statement. I thought it's gonna give me something else. So both are true, it give me true. Both are false, it give me false. Now true and false. Okay. So I told you that we multiply. Okay. There is at least one false right here. It gave me false. Oh, that's a combination, right? I am checking this one. And there's one true, then true. Then what AND operators say? It says if at least one is false, it will give me false. Is there any false? No. Second, is there any null? One null, it give me null. It give me null. Okay. Now check for OR operator. What it says? At least one is true. It give me true. Is there one true? Yes, true. It give me true. We are true. We are done. Now get with again and. If there is one false, it's gonna be false. It is false. What OR operator say? If at least one is true, it has to be true. There is no true. We will move to second. Is there a one null? It will be null. No null. Third is like if both are true, it's true. If both are false, both false. Both are false, false. Now let's do this one. What Anne says. Anne says if at least one is false because it's multiplication. If one is zero, everything is zero. So one is false, it's gonna be false. So yeah, one of the condition give me false. So that's a false. Now check for OR operator. What it says is my plus addition, right? If there is one value that is coming, that means everything is one. So if it is one is true, everything is true. There's no true here. Second, if it's null, it will be null. Is null, correct. But now again, both are null. It's gonna give null. I rest my case. This is interesting. And op now and an or is done. It give me one value. If you want to reverse the value, make it true to false, false to true, null will remain null because it's empty, right? So you do it not reverse the boolean, not whatever the condition is. If it's coming null, it will remain null. If it's true, it's gonna be true. It false, it false. So not operator is interesting. Not reverse the boolean. So not if expression is there, it give me true, it will become false. If not expression yield me false, it will reverse it to true. If not expression result me null or empty or unknown, it give me null empty. And with this, I think we can wrap today's video. We learned a lot, especially about AND and OR operator, and I'm really grateful that I did that. So today we are done with where clause, from clause, and or logical operators that logically connect the booleans together and give the results. And we are very much clear with the logics as well. So with this, I think we will wrap today's video. I'm really grateful that everyone joined. Yes, see you in the next video tomorrow. And I think today, I'm going to do one more session of AWS. Let's meet again. With this, I will take my leave. Stay tuned, stay healthy. Let's connect.